sine and cosine laws. Examples. Find theta given that theta is here and this is 3, and then this is 45, 60, and this is 4. The sides given are not surrounding any angle. The angle given has a side missing. But the angle we're looking for has its side present. And there's a full set. There's an angle and the opposite side is given. Mean that we use sine rule. So say 4 over sine 60 is equal to 3 over sine theta. To cross multiply, you get 4 sine theta is equal to 3 sine 60. Then this is 4 sine theta is equal to sine 60 is what? 3 over 2. Then divide by 4. Divide by 4. So we get that sine theta is equal to 3 root 3 over 8. So theta is equal to sine inverse of 3 root 3 over 8. But if you are given to find, if you are told to find just here, you are told to find A. Let me say find A in part 1. So for us to find A, you need the side. So, okay, let me not use part 1. Let me say find A given that you have a triangle of this form. This guy here is 60, and that is 2, and this is 3, and this is A. Find A. So to find A, you say, since I'm looking for the side, and I'm given its opposite angle, and that angle I'm given, the sides surrounding that angle are given. So you can use A is equal to, A squared is equal to 2 squared plus 3 squared plus what?
Minus cos
Minus 2, 3, 2 cos 60.
Cos theta.
The inner angle, so that here we get 4 plus 9 minus 12 cos 60 is what? Is half. So we have 13 minus 6 giving us 7. So a squared is equal to 7. And so a is equal to 7. This is when you use sine and when to use cos. The cosine law or the sine law.
So can you explain how you came about with the formula?
So where the formula is a squared is equal to b squared c squared minus 2 bc cos a. Where is the angle inside? So a is the square root of this. This is what we call the cosine law. How do you know I must use the cosine law? You want to get this side here. To get the sides, you have an angle opposite to this side. Sine law requires that you should have another angle. If you had this angle, so that you can use this pair, or you have this angle so that you can use that pair against the missing pair. But now we only have the angle and the side surrounding that angle. And the side that you're looking for has an opposite angle inside. Then you know it's cosine law. Then if you are given a vector,
Sir,
hello,
sir,
hello.
can you just go back to the previous screen? I want to screenshot. We can proceed.
If you are given a vector u1, u2, to find a unit vector in the direction of u, you just get the magnitude steps. Find the magnitude of u. Step 2, divide u by its magnitude. The recording will be sent there. So, meaning that the procedure here will give us then the unit vector. I did not a unit vector. So I'll do just like this. This is how that is not. So unit vector in the direction of u is going to be U as a vector over the magnitude. I'll give you an example. I'll give you an example when I about that. Okay, example. Find a unit vector V in the direction of U to not 2, 4, 3. So say V is going to be U over this. But to get the magnitude of U, you get the square root of 4 squared plus 3 squared. This is 16 plus 9, which is 25, giving us 5. So V is going to be 4, 3 over 5. This is a vector, which you can also write as 4i plus 3j over 5, which is the same as 4 over 5i plus 3 over 5j. This vector here is unit. A unit vector has its magnitude 1. Let's check. What's the magnitude of V? It will be the square root of 4 over 5 squared plus 3 over 5 squared, which is 16 over 25 plus 9 over 25. That is 25 common denominator, and then 16 plus 9, giving us 25 over 25, which is equal to 1. Then you know it's a unit vector. If they ask you to check if the given vector is unit, you find its magnitude. If the magnitude is 1, then the given vector is unit in the direction of n vector mentioned. Then there are also properties of vectors. But before those properties of vectors, okay, first properties and then the angle. Then I'll take
Can
you
I just
to
screenshot
the matrix. I can even film the video.
Thank you.
Yeah.
Sorry.
Then
So when they
okay, so Jomba,
Sir,
properties.
So
Hello.
what about the unit vector in the opposite direction?
You first get the opposite direction vector, and then get the unit vector of that.
So
Mhm.
I had a question on the previous thing.
What was your question?
My question was the last thing that you found was that what's the difference between the direction and the unit? Finding the unit thing.
That's the question again.
Like the first part, what did you find? Is that the direction? Like I'm asking what you found.
This is the unit vector. And we are confirming if it is indeed a unit vector. A unit vector has magnitude 1. We checked, the magnitude came out to be 1. Then we said it is indeed a unit vector. So the direction, the unit vector will be in the direction of u. So the u will be given. Yours is to find the unit vector. Okay. Now, Kaidi, I want to know that now that the message that is asking a question, since you have overloaded the thing with charts, anyway, properties. If you have vectors A and B and a scalar K, then 1, the dot product of AB is the same as B dot A, since it always comes out as a scalar. And then 2, excuse, 2, if you are dotting A, let's say also have vector C, B plus C is the same as having A dot B, and then you add A dot C. 3, if you have a 0 vector and you dot it with A, you will get a 0 vector. Now the dot product don't get a vector. So if you have a 0 vector, you dot it with A vector, you get 0 as a constant. Then 4, if there is some scalar and you are doing a dot product here, let's know that you are also free to multiply that scalar with one of the vectors if you want, and then dot to the other vector. And the scalar can jump. You can also have A and then dot in this form. And 5, if you have A and you're dotting it with itself, the same as getting the magnitude of A and square it. So this one is too light, so I'll give you an example. Then an angle between vectors. So what now to define another way you can check if two vectors are perpendicular or parallel using an angle. Now, how do you get an angle between vectors? Okay, you can use one. You can get theta by getting the dot over. So you get that product and divide by the product of the magnitude. This will also give us a formula that you can actually get the dot product using the magnitude and then multiply by the angle. That is, if you cross multiply, you get such a thing. An example, Let's do this example so that we don't forget. Find theta between vectors A 3,1 and B 2,-1. So you say cos theta will be equal to A dot B over A B. So what is A dot B? It's 3,1 dot 2,-1, which is 3 by 2 plus 1 by -1, giving us 6 minus 1, which is 5. And then what is magnitude of A? The square root of 3 squared plus 1 squared, which is 9 plus 1, which is 10. And then B, the square root of 2 squared plus -1 squared. That is 4 plus 1, which is root 5. So that cos theta is going to be 5 over root 5. So theta, so theta is going to be cos inverse. No. That one can't exist. We left out one. Suppose the product, root 10. So that here we are saying that cos theta is the same as 5 over, this is just the same thing, I'll repeat. It is 2 by 25, which is 5 over 5 root 2. So these will cancel and get 1 over root 2. So cos theta is equal to 1 over root 2. So theta is equal to what? You always get an angle from the first quadrant. So what is theta here? 45 or 5 over 4. Now that we are able to obtain an angle, we can also define.
And before you proceed, can you explain how you balance 5 over 5 and have the 5 over
5 over root 5 by root 10. From SADS, if you have root A, root B, you can write it as A by B. So we have 5 on top, so we can write it as 5 by 10. This is 5 over 50. But 50 is the same as 2 by 25. So we'll write it as 5 over the root of 2 by 25. And again, separate now in reverse. So this is going to be 5 over root 2 root 25. But root 25 is 5. 5 in 5, 1. 5 in 5, 1. So we get 1 over root 2. So now look at this. Because you can find the angle, you can also define, you can put a condition for two vectors to be parallel by saying vectors A and B are parallel each other, or they are parallel vectors. Parallel if the angle between them is 0 or 180, 0 or pi, then they'll be parallel. And two perpendicular or orthogonal vectors if the angle between them is 90. Then you can tell us, oh, since the angle is 90, then these vectors are perpendicular. Then vector projection. You know,
So how can you verify if the vectors are orthogonal when you're given 4 vectors?
the vectors, whether they are 4 or 100, you are checking orthogonality between pairs. So if you have vector u, v, w, z, you check if u is orthogonal to w. Check if w is orthogonal to z. So you keep checking in pairs. Then we have the projection, vector projections. So you say the vector projection of vector B onto vector A is written as projection of B on A is given as A dot B. So A only appear once. I mean, B only appear once. You can actually write it like this so that you have no confusion. B dot A over A squared dot A. Not necessarily dot, because if it's a dot, then we'll get a constant. So we multiply by A, the vector. The top one is a dot product. The down one is the magnitude squared. And then multiplied by vector A. So the projection of B onto A, in the formula, B only appears once on the dot part. Then we also have scalar. So if I can include scalar here, we'll say scalar projection of B onto A. This one is noted as component. So we say the component of B onto A is given by B dot A over the magnitude of A. This one, A appears twice, B once. Here you need an example. An example, find the scalar and vector projection of B onto A. If A is equal to 0, 2, 3, and B is equal to -2, 1, 1. So you say, you can start with the scalar, the component B onto A is given by B dot A over this. So we get B dot A. So B dot A is given by 0, 2, 3 dot -2, 1, 1, which is 0 times -2 is 0, plus 2 times 1, 2, 3 times 1, 3. So you get 5. Then you get the magnitude of A, which is the square root of okay, anyway. So here I've written in the form A dot B. But because you said that they're the same, the order here doesn't matter. So here we have 0 squared, 2 squared, plus 3 squared, giving us 4 plus 9, which is 13. So we come back here and say, okay, it's going to be 5 over 13, the square root of 13. But the projection of B onto A is given by B dot A over this guy squared A, which is going to be 5 as the dot product over root 13 squared multiplied by A, which is 0, 2, 3. This is 5 over 13, and then 0i 2j plus 3k. This is the project. So the projection will be a vector, and the component will be a scalar. That's how you find the projection and the scalar component in that order. So this guy here can be written also as a vector in component form, where you say 0, and then 5 by 2, you say 10 over 13, and then 15 over 13, if you are taking them inside. So you're multiplying as you take. Remember, when you write in this form, no ijk. Okay, so the 4 minutes will cut. Quickly come back. We finish this. Just remaining with few concepts here. So that when we look at the table sheet, even if you missed a lecture, this is just a summary of the whole lecture you are doing. So let's come back.